All right. Hello, grade 11s. I hope you guys are well. Okay, we're going to do some grade 11 stuff because we've been doing exponents and surds. So right now I'm going to do a certain aspect of surds that's called rationalizing the denominator. Okay. I hope the connection there is good. If you can just double tap for me in the screen. I hope everything is fine. I don't know if the network is good. Am I lagging? Are we good, guys? Can you just confirm for me in the comment section that we are good? Okay, so guys, let's go. We are going to look specifically at a concept that we call rationalizing the denominator. Okay, I'm going to explain what it is so that we can slowly but surely unpack and unravel what the concept actually means. Okay, so we learned that to avoid having surds in the denominator. By the way, not having surds in the denominator is a mathematical practice that is observed when we have irrational numbers in the denominator, in other words, a surd. And guys, you'll remember that a surd is simply an irrational number. That's what a surd is. Okay, so to avoid having surds in the denominator, we multiply the given fraction by what, guys? By a unique form of 1. Okay, we multiply the fraction by a unique form of 1. As I explained, a surd is an irrational number. So any number underneath a square root, which when expressed is an irrational number, we call that a surd. The square root of 25, for instance, is not a surd because the square root of 25 can be simplified and it is equal to 5. So surds, when we simplify the square root of 3. So for instance, if I put the square root of 3 in the calculator and I press equal, alright, I still get the square root of 3. So any number that still maintains, alright, the root after simplification is what we refer to as a surd, because it is an irrational number. Irrational in that if you were to see the decimal of it, the numbers after the comma are non-recurring and they are non-terminating, not repeating and never ending. All right. But on the other hand, if you were to take the square root of 25, this is not actually a surd, because the square root of 25 when simplified gives us 5. Okay? Though we can express 5 as in surd form, but it is not actually a surd when simplified. The square root of 3, on the other hand, is a surd, because even after being simplified, it still is a number under a root. So therefore we refer to this as a surd. So to avoid having a number that has a root in the denominator, we do something called rationalizing the denominator. How? We multiply that given fraction by a unique form or a special form of 1. So the surd is eliminated in the denominator. We multiply the fraction, thank you Mario for the rows, by a unique form of 1, so that the surd is eliminated in the denominator. Remember guys that when you multiply any number by 1, you get that number back. Multiplying a number by 1 does not change that number, because 1 is what we call an identity element. So the thing here that we do when we rationalize a denominator is we multiply that given fraction by a unique form of 1. We're going to see what that unique form is. But remember, when you multiply that fraction by 1 in and of itself, it does not change the fraction, essentially. So the surd is then eliminated in the denominator when we multiply by this unique or special form of 1. So let's really look at an example so that you guys can understand what we mean by multiplying by a unique form of 1. So we are given here the 3 over the square root of 2. When you look at this fraction, you observe that in the denominator we have what we call a what, guys? What is the square root of 2? What do we refer to this as? The square root of 2, even after you take your calculator and you say square root of 2, you still get the square root of 2. That means this is a what, guys? It's a surd, an irrational number. We cannot have a surd in the denominator. We cannot have what? A surd in the denominator. We can not have a what, guys? We cannot have a surd in the denominator. We can't have a what, guys? We can never ever have a surd in the denominator. So what we do is we multiply this entire fraction by 1. Right? But this special form of 1, guys, is a 1 that is expressed in the following way. Do you see the square root of 2? I am going to multiply by that same square root in the denominator. That same square root of 2, I'm going to also multiply by it in the numerator. So whenever you have a single surd in the denominator, you multiply by that same surd in the denominator, but also in the numerator. Guys, this is what we call our special or unique form of 1. Root 2 over root 2. Doesn't that give you 1? Isn't root 2 over root 2 actually equal to 1? That's my question to you. Isn't the square number divided by itself giving us 1? Doesn't a number that we divide by itself give us 1? Hopefully we all agree that it does. So 3 over root 2, if we want to multiply this fraction by a unique form of 1, that unique form of 1 is actually root 2 over root 2, because we are saying we are multiplying by a unique or special form of 1. What guides us in forming the special form of 1? We are guided by the surd itself. We place that surd in the denominator, we place that same surd in the numerator, then we multiply that with this entire fraction so that we can get rid of the surd in the denominator. Let's look at another example, guys. So I'm not done with that question, but I just want to make the point. Let's say we had 4 over root 7. What would be the unique form of 1 that I would multiply 4 over root 7 by so that I can rationalize the denominator? I said we would multiply by a unique form of 1. What is that unique form, guys? In the denominator. Okay. Do we agree that this is a surd? Square root of 7? Yes, it is, because the root does not go anywhere when you apply this surd. Okay. So therefore, the unique one that is going to be multiplied is root 7 over root 7. Doesn't root 7 over root 7 give me 1? Yes, it does. Therefore, this is the unique form of 1 that I'm going to multiply the fraction by. Why? So the surd is eliminated where? In the denominator. Okay? So I hope you guys understand that when we say we are rationalizing the denominator, the minute there's a single surd in the denominator, we simply multiply by that very same surd, bottom and top. The minute there's a single surd in that denominator, whatever it is, we simply multiply by that same surd, bottom and at the top. Now let's continue. In the numerator, 3 times root 2 is 3 root 2 over. In the denominator, root 2 times root 2 according to our laws is going to be root 2 times 2. When we are multiplying roots that are the same, we simply write the multiplication of those numbers underneath the roots, underneath the same root. Because this is the square root for both, we write the 2 times 2 underneath. Because this is square root, we write it underneath the square root, multiplying the 2 and the 2. 2 times 2 is 4. What is the square root of 4 in the denominator? That is equal to 2. Is there a surd now in the denominator, guys? Do you see a surd in the denominator still? Hopefully you can see that we don't find any surd in the denominator. Rather, we have a surd in the numerator, and that is fine. Can we simplify any further? Can 3 be divided by 2? No. So this is our final answer. We have just rationalized the denominator. In other words, we changed an irrational number surd to a rational number. How? By rationalizing the denominator, by multiplying by a unique form of 1. Okay? If you guys have any questions, you'll ask. If not, I will continue. This example, we also found that there was a surd in the denominator, in other words, an irrational number. We multiplied by the unique one, which is root 7 over root 7, because in the denominator we have root 7. Then when we multiply 4 times root 7, we have 4 root 7. In the denominator, we know that when we multiply, we are going to have the square root underneath 7 times 7, which gives us 4 root 7 over what? What is 7 times 7? It is 49. And we know that the square root of 49 does not remain as an irrational number, or as a surd, sorry, but we can express it as a rational, which is what? Positive 7. Can we simplify any further? No. So therefore our answer is 4 root 7 over 7. That is how we do questions around rationalizing the denominator. These two examples where there is one surd in the denominator. Where there is one surd in the denominator. Yes, later on in the evening, Liam, as usual. Okay. Grade 12, I do it in the evening. Night time, actually. After 9. Okay. After 9. Grade 11 right now. Okay. So these two examples, I hope, are fine. Okay. Functions, Liam. We started with functions yesterday. We are continuing on with functions. Let's look at this one now. If we look at this fraction, we have 3 in the numerator. In the denominator, we have 2 minus root 4. Here, we want to simplify. All right. Okay, I just want to change this because... Okay, let's just... If you look at this question, that's 3 over 2 minus root 4. In the denominator, guys, 3 over 2 minus the square root of 4 we know is 2. Okay, 3 over 2 minus 2, what's 2 minus 2? It is 0. So therefore, what is 3 over 0? I'm gonna wait for someone to answer. What's 3 divided by 0, guys? What would be my final answer? What would I write there as a final answer? What would I write there as a final answer? Mr. BP Lushaba, you are a teacher. Of course you would have known the answer. You funny man. Okay. Well, I sure hope all of you understand that it is undefined. It would be very sad if I would see people saying the answer is 3. Like Notando is saying 3 divided by 0 is not 3. 3 divided by 0 is not 0. 3 divided by 0 is undefined. So I'm 100% correct, Mr. BP Lushava. You are a teacher with your beautiful family there in the profile. Wonderful family, by the way. I love the matching tops there with your wife. It's beautiful to see. Keep it up. Keep up whatever you're doing in your home, and never let that love die. Never let that marriage fail. And be true to who you are. Yeah. Let's look at this question, guys. Two over 2 minus square root 5. Okay. Now, if we look at this question, this one was quite nice, because we did not have anything that was irrational in the denominator. Square root of 4 is going to give us 2, so that means we did not have an irrational fraction, an irrational denominator. No surd was actually found after simplification, therefore we could proceed nicely. And obviously just make sure that we don't forget that any number divided by 0 is undefined. Let's look at this example. 2 over 2 minus root 5. If you look at this question, you have a 2 there. There's one term in the numerator. In the denominator, there's two terms. There's the 2 minus the root 5. This root 5 is obviously going to be an irrational number. And if you take an irrational number, guys, that is negative, and you add 2 to it, this still leaves the denominator being irrational. So in other words, even though there are two terms, this all is irrational. So what then can we say about the denominator? The denominator exhibits that quality of being irrational, and therefore it means that we need to get rid of the surd in the denominator. You know, still got surd qualities. We need to get rid of the surd. So we are going to have to multiply this entire thing by a unique form of 1, the special unique form of 1. All right. So now listen to me and listen to me well. In the denominator, we have two terms. They are separated by a negative sign. So typically I'd want to multiply by 1, but the unique form of 1, when there are two terms, we multiply the denominator by the same first term 2, the same last term square root 5, but we simply change the middle sign that separates to plus, and we close the bracket. So that means at the top we are going to do the same. This divided by that, something divided by itself, is equal to what, guys? 1. Our unique form of 1 is the same terms, right? Just with a different sign in between. Now, if you are a grade 11 learner and you are looking at this, then it hits you in the mind that, oh, this is the reverse expression form of difference of 2 squares. And obviously, that will mean that we will be successful in eliminating the denominator for as long as the signs for the 2 brackets in the denominator are different. And we can see that the first and the last values are the same though, but with different signs. So the root, the surd, will definitely be eliminated if we multiply by this special form of 1. How do we find this special form of 1? We find it by, if there are 2 terms, as I said, in the denominator, we multiply the denominator by the same 2, the same root 5, just with a different sign in between. We call this here the conjugate. If we are getting into mathematical terms, the what? The conjugate. Why? Because the conjugate of 2 minus root 5 has what? The same terms, but different sign. Same terms, same 2 terms, but just with different signs. This is what we call the conjugate. Okay, so now we can proceed, because we have the special form of 1 using what we call the conjugate. That's what we do when there are 2 terms in the denominator and we have a surd. We multiply by the conjugate, and we use that denominator conjugate and write the same thing in the numerator. This forms our special form of 1. Now, are you ready to multiply? Because when you multiply the denominator, you are simply going to apply FOIL. What is FOIL? We are going to distribute the first term, 2 times 2, in the denominator. All right, so in the denominator, I just want to show you what the answer will be in the denominator. I'm going to come back to the numerator. In the denominator, 2 times 2 is 4. 2 times you multiply the outer terms. 2 times root 5 is positive 2 root 5. You multiply the inner terms. Minus root 5 times 2 is negative 2 root 5. And last but not least, minus root 5 times another root 5. That will simply give you a negative underneath that 5 times 5. You write down the 5 times 5, which will obviously give you 25 in the square root of 25 in that particular position. Okay, let's go now back to the numerator. The numerator, we have 1 into 2 terms. So you simply distribute the 2 times 2, that gives you 4. Then 2 times root 5, 2 times root 5, that gives you 2 root 5. Now we're getting close to the answer, and you know what's nice is that in the denominator, it's very clear that we are not going to have any surds that are going to be there. Why? Because the 4, now look at this middle here, the 2 middle terms, 2 root 5 minus 2 root 5. When you subtract something from itself, you get what? 0. So that means this and that are gone. We don't have the root 5, the 2 root 5 and the minus 2 root 5, because when you subtract them, we get 0. The last term is going to be minus 5 times 5 inside that square root is 25. I'm sure you guys can see already what's going to be happening there in the denominator. I'm sure you are seeing what's going to be happening there in the denominator. We have 4 minus, what's the square root of 25? It is 5. Do you see any surd now in the denominator? I'm sure you see no surd in the denominator. We have successfully eliminated surds. Finally, we have 4 plus 2 root 5. 4 minus 5 is negative 1. And guys, all we now do is we say this divided by negative 1. That divided by negative 1 is simply negative 4 plus 2 root 5, which when distributed, the negative inside the bracket will give us negative 4. Negative 4 minus 2 root 5. This is our final answer. No surds anymore in the denominator. And we've successfully eliminated the surd that we initially had by multiplying by a special form of 1. Okay. Take it in. If you have any questions, ask. The comment section is yours to ask. So the minus is not including the number in the square root. I don't understand what you're saying. So the minus is not including the number in the square root. 4 plus 2 root 5. 4 minus 5 is negative 1. Then you are taking this dividing by negative 1. So a number divided by something that is negative. No. The minus 5. This minus 5 is outside the square root. This minus 5. Okay? Yeah. So square root of 25, that's positive. The minus is outside. It's not inside. It would be a different story if the minus was inside. It's outside. Okay, then you get the square root of 25 is 5. The minus is outside, so it's 4 minus 5 now. Okay, and then 4 minus 5 is negative 1. You take this, you divide by negative 1. That would mean that the answer will be negative, because a positive divided by a negative gives you a negative something. It's a negative this. But then that negative you must distribute into negative times 4 is negative 4. Negative times positive 2 root 5 gives you negative 2 root 5. So finally, that's how you get to that answer. All right. So our special form of 1, when we have 2 terms in the denominator, and it is surdy, in other words, the rational number is there, then we multiply by the conjugate. Same terms, different sign. That's all. And you set it up the same in the denominator as well. This 2 and the root 5 is your guide, but then there's a sign change. That's all. The sign change is important there. You multiply by that. That's your special form of 1. But if you are wanting to get rid of a surd where there is one denominator or one term in the denominator, you simply multiply by that same denominator and you set up your conjugate using that same denominator for your numerator, and you simplify from that point. So one surd denominator, you multiply by that surd in the denominator and the numerator. 2 terms in the denominator and there's a surd, you multiply by the conjugate. What is a conjugate? It's an expression with the same terms but with a different sign from what you had in the denominator. And it works like a charm, so that you are able to do what at the end of the day? Eliminate the surd from the denominator. Okay. What do I feel like you're answering your own question, because you're asking me what is the difference between minus root 5. It's in exactly what you are saying. What is the difference between minus? What is the difference? So basically you are asking me what's the difference between this and this. Okay, this is a negative irrational number. So this number is irrational. This here is non-real. Okay. This is a negative irrational number. This here is a non-real number. It's imaginary. Okay, it's a complex number. That's the difference. Okay, I'm not really expecting to be explaining differences such of this nature to grade 11s, to be honest, because remember, these concepts are grade 9 concepts, further explained in grade 10. When you are in grade 11, really and truly, I'm not expecting to be talking about such concepts, to be honest. But if you are having an issue with these, it means that you are careless. You are careless in your conceptual mastery, and therefore it's going to cost you big time in grade 11 and 12. And honestly, that's probably one of the reasons why most learners don't do well in mathematics. It's because they are careless, they don't care. And it's like the basics that are literally taught and are taught well. There's no sense of caring. It's good that you are asking, and I'm just answering myself as well, because that is the reason. I'm trying to also at the same time kill 2 birds with 1 stone. Your question is good, but your question also is a frustrating question to someone who you are expecting to understand certain things because they are in a certain level of the grade and understanding, but then they don't understand those things. The marks, the loss of marks, their inability to apply concepts to other topics in this specific grade are going to be hinging on your understanding of what you learned earlier on. So if there's a lack of that understanding, that's where things go wrong. But if there's a full and complete understanding of certain concepts done earlier, then it makes life easy for you as you go along. Okay. So I'm simply also answering and also trying to clarify something that is very sinister about why kids do not really, solidify mathematical understanding as they ought to, and therefore don't attain marks that they ought to be attaining, and are simply getting mediocre marks there and there. Guys, I was listening to someone just explain, for instance, the educational system in Korea, and how kids from a very young age, they literally don't have time to themselves. Like, they learn these people from literally the early hours of the morning until literally late into the night. By the time they get home, they crash and they just are too tired. And the same process repeats itself the next day. These kids literally don't have a break. Unlike kids here in this country, you have tons and ample loads of breaks, but more than that, the minute someone is doing something on a live, people are like, no, people are supposed to have a holiday and all of that stuff. And that's probably why we are also not, I don't know, thinking really like I don't know. It's just many things. Want to take a screenshot? Here you go. There is the screenshot. This is the entire screenshot of what I've started with, rationalizing the denominator. Okay, and what rationalizing the denominator means. Okay, we want to avoid having surds in the denominator. To avoid having surds in the denominator, what do we mean by surds? We mean such. Okay, such irrational numbers that have a root. Square root of 25 is not a surd, because square root of 25 is 5. This is a rational number. Square root of 3 is an irrational number. It's a surd. Okay. So rationalizing the denominator is something that we do to avoid having surds in the denominator. We multiply a given fraction by a unique form of 1 so that we eliminate the surd where in the denominator. So I looked at 3 examples just to sort of like explain this concept a bit better. And that is, if you have a fraction, you have a surd in that denominator. Okay? You have a surd in the denominator. Okay? Can you see the surd? Then we eliminate, because in mathematics it's a common practice that we don't want to have a final answer that has a surd in the denominator, an irrational number. So what we do is we multiply the fraction by a special form or a unique form of 1. How? Because remember, when you multiply a number by 1, you get that number back. So multiplying by 1, because 1 is what we call an identity element. When you multiply a certain number by 1, you still get that number back. So you have this 3 over root 2. We multiply 3 over root 2 by a unique form of 1, which is the denominator, which is 1. We multiply that denominator. We take the denominator and we use it as a guide as to what number we need to multiply by. So if it's square root of 2, we multiply in the denominator by the square root of 2. We do the same thing in the numerator. Remember, square root of 2 over square root of 2. What is the square root of 2 divided by the square root of 2? Doesn't that give us 1? It is 1. So this is the unique form of 1 that we are multiplying this fraction by. Why? Because it will help us eliminate the surd in the denominator. So in the numerator, what's 3 times root 2? It's 3 root 2. In the numerator. In the denominator, what's root 2 times root 2? That simply gives us the square root of 2 times 2, which is the square root of 4, the square root of 4, which gives us 2. Okay? So we've basically changed an irrational number, square root of 2, to become a rational number. By that, what have we done? We've rationalized the denominator. We've changed it from irrational to rational, because 2 is a rational number, whereas square root of 2 is irrational. Okay? So that's how we rationalize a denominator. If there is 1 surd in the denominator. Okay? So I then sort of like hit the hammer of this thing by writing another example. What about 4 over root 7? How do we rationalize 4 over root 7? What do we have in the denominator? Root 7. So we multiply by root 7. But what we do at the bottom, we do it at the top. What's 4 times root 7? 4 root 7. What's root 7 times root 7? That gives us square root of 7 times 7, which is square root of 49, which is 7. The denominator has been rationalized again. Okay, so this is what we do when we have one surd in the denominator. We simply multiply by that surd, bottom and top, so that our unique form of 1 is actually there. Okay, Ngwato, you are actually agitating me a little bit now in the comment section. I don't know why you sending questions. I don't know why. Okay, I don't know why you are doing that. I explained to you that there's the difference between negative square root of 5 and square root of negative 5. This is irrational. This is non-real. Okay, so you will get an actual value here, but here it's non-real. It's imaginary. This is an imaginary number. So with your question, you need to apply the logic. What you're asking me is, you tell me what is this the root of negative 5. Root of negative 5. Okay, it means you have a negative number inside the root. So what is that? You tell me in the comment section. Okay, I think Wato, you told me as well that you're actually not a learner. Okay, so that's kind of also something that's probably a bit agitating. I'm trying to explain a concept for grade 11s, but there's questions you keep on sort of like asking in the comment section which are not related to what I'm doing. Okay, so that's something else. And remember, these are high school learners. Complex numbers, as I have been saying and I've been explaining a lot, complex numbers, we don't go deep into, for instance, what Sekhamez is saying in the comment section. We don't talk about that, the 5i, because within the context of the syllabus for CAPS grade 8 to grade 12, for South African learners, we don't do complex numbers in depth. We are only doing it where at varsity. So please, guys, okay? Yeah, please, you guys, that's why I was saying, you guys that are in other, if you finished with high school and you are here and you want to showcase your prowess and your skill and all of that, this is not what this is about. This is me trying to help learners that are in high school to be able to understand the basics in the context that they are in. So if you guys are going to deter me from that, then I'm going to see you as enemies, and I'm going to actually eventually just end up saying, okay, guys, I think you need to please leave the live so that I can actually attend properly to these learners. Okay, and I'm not being unreasonable in that. I'm just being reasonable within the context of what I'm doing, understanding what the learners have to be focusing on. So please, guys, please, yeah. Otherwise, yeah, I mean that in good spirits, please. Okay, then we look at this example where we have a denominator, and in the denominator this time round, it's not one term that's there, we have 2 terms. All right, okay, so this question we were able to answer. We have 3 over 2 minus root 4. Root 4 can be simplified. The square root of 4. Okay, the minus sign is outside, so the square root of 4 is 2. Right, so once we get the square root of 4, we get 2, that minus sign, 2 minus 2 is 0 in the denominator. Now 3 divided by 0 is simply undefined. A number divided by 0 is undefined. Very different from when we have a negative number inside the square root, because we don't say this is undefined, we say this is non-real or imaginary. A negative number inside an even root is non-real or imaginary. But a number divided by 0 is undefined. 2 different concepts, they don't mean the same thing. Okay, let's look at this question now. Okay, then I also looked at this question where there are 2 terms. It's clear here in this denominator. Square root of 5 is irrational. It is a surd. We have 2 minus the square root of 5. So this square root of 5 is irrational. It makes the entire denominator, 2 minus the square root of 5 makes the entire denominator irrational. So it is a surd that we have of 2 terms, different from when we had a surd of in the denominator, one term. We now have a surd of two terms, separated by a minus sign, the two terms in the denominator. So what do we do with that one? We still multiply by a unique one, okay? We will still multiply by a unique one. Thank you, Sekhamit. Please do answer Ngwato privately in a private conversation. That would be really appreciated. Let's not deviate from, yeah, please guys, please. 2 over 2 minus root 5 times 1. This one here, as I am explaining to you, is actually the unique, we multiply by 1, we still get the same fraction that we have here. But the unique one we are going to form is going to be formed on the basis of the denominator. We multiply the denominator by what we call the conjugate. The word is conjugate. What it simply is, guys, is that you see these terms. This is a 2 root 5. You write another square root of 5. You see this sign here for this expression was minus. We don't write a minus with what we multiply by. We write a different sign opposite to this one. So we write a plus sign. And then obviously this expression is what you write in the denominator as well. This divided by that, doesn't that give you 1? Yes, it does. So the unique one we are multiplying this fraction by is 2 plus root 5 over 2 plus root 5. Same terms, just different sign. Please guys, that is what we call the conjugate. Same terms but with different signs. Then you just do the algebra after that. In the numerator, 2 times 2 is 4. 2 times root 5 is 2 root 5. 2 terms in the numerator, that's good. In the denominator, you have 2 brackets. So you apply who? FOIL. Multiply the first, multiply the last, multiply the inner terms, multiply the last terms. You get 4 plus 2 root 5 minus 2 root 5 minus, in the square root, 5 times 5. In the numerator, you still have 4 plus 2 root 5, that's fine. In the denominator, 2 root 5 minus 2 root 5 will give you 0 because these are like terms. These are like terms. Remember, the rule says when you have root 5 and you have an addition and a subtraction, you treat these as like terms. This is like your variable. Root 5 is like your variable, and then this 2 and this 2 are like your coefficient. So you keep the variable root 5, and then you say 2 minus 2, which is 0 basically. You get 0 root 5, which is 0. So there's no root. There's no surd, okay? Then you work out minus, what's 5 times 5 inside the root? It's 25. What's the square root of 25? It gives you 5. So in the denominator now you have 4 minus 5, which gives you -1. And then from there, guys, you ask yourself, what is this divided by -1? That gives you negative all of this. So you put it in brackets, negative what? 4 plus 2 root 5, and then you distribute the negative sign. Negative times 4, -4. Negative times positive 2 root 5, -2 root 5. This is what we mean by rationalizing the denominator, specifically using what we call here for 2 terms in the denominator where there's still a surd and this is all irrational, specifically using the conjugate. Same terms, different signs, and you basically form your special one that you multiply by to basically get the denominator not being a rational number, an irrational number, sorry. Okay, any questions? Okay. Yeah, that's what it is, cool, Chris. Yes, the rule does say that any number multiplied by 1 becomes that number. Okay, so in essence, the final answer you get here is not something different from this. But what makes it unique is that we don't have a surd in the denominator, which is what we want to make sure is the case in our denominator. We want to ensure we don't have a surd featuring in the denominator. That's how we make sure we are able to rationalize the denominator. Let me just recap again. To avoid having surds in the denominator, because in maths, that is a common maths practice. We avoid having surds in the denominator. We do that by multiplying a given fraction by a unique form of 1. Because as you said, cool Chris, a number multiplied by 1 is that number. Are we together? It does not change the number's character per se. So we do that so that we can do what? We are able to eliminate the surd in the denominator. Okay, I think that was the second time round explaining this thing. So I think now let me give you a chance. All right, these are some problems that I'd like us to look at, knowing what we know now. Okay, so it'd be good for you to get a screenshot of this, and then we can take each problem one by one and dismantle it so that we can see that we have understood the concept well, and also other concepts that we've covered yesterday when we were doing surds and roots. Okay, so let's come to this first question. Root 3 over root 12. Okay, root 3 over root 12. Now, in this question, immediately when you look at it, I guess there is, what we see here is a root at the top. Thank you, Nolitha, for the help me, really appreciate it. We have a square root of 3 here, we have a square root of 12. These both have roots, and the roots, this is a square root, this is also a square root. So there are laws, guys, that we've learned about roots as well. So really and truly, rationalizing the denominator wouldn't be really, for me, the first thing I would think about. All right, it wouldn't be the first thing I would think about. I would also think of alternative methods or alternative way to do this question. So for instance, here there is a law that says when you have separate roots like this and they are both square roots, then you can actually write this 3 and 12 underneath one common square root. Just like when you are dividing the square root, you can split it into square root of 3 over square root of 12. Okay, so that's very nice to actually take into consideration. Where do I get these separate answer sheets? These separate answer sheets, I get them from a book. Okay, get them from a book. Once you see most your book, you see most the book has these things. When you take the book apart, okay, here's my A72. You can see it's empty. So you pull it apart and you take out the staples. That's where you get the things being separate, right? And you are able to separate the papers. I hope that makes sense. Okay, so yeah, so like I said, guys, we can actually join 3 over 12 underneath the same house, because this 3 is under this house. Thank you, Sakamete, for the you awesomes. This 12 is underneath a very same house. So you can then write this 3 and this 12 underneath each other, underneath the common house. Oh, okay, I see. No, I hear you, Samamkel. I hear you. All right. Then, what's 3 divided by 12, guys? What's 3 divided by 12? 3 divided by 12 underneath the square root. Thank you, Nolise, for the finger heart. Really appreciate it. 3 divided by 12. I'm sure you guys know that 3 and 12. 3 goes into 3 in the numerator how many times? Once. Whereas 3 goes into 12 how many times? 4 times. But remember, the square root is still there. I think now at this stage, okay, it's safe to say that if you want now, because 1 is a perfect square and 4 is a perfect square, you can re-separate the roots. Square root of 1 is 1, square root of 4 is 2. So your answer is 1 over 2. Simplify without using a calculator. This would be one of the ways in which you could easily just simplify without using a what? A calculator. Okay. Now someone else may approach the very same question differently. Okay, they see this question and then they decide, I can see that the denominator is a what, guys? It is a surd. What do we mean that the denominator is a surd? It means that the square root of 12 is an irrational number. So one may decide to multiply by the unique special form of 1. So what they do is they say the square root of 3 over the square root of 12. Let us multiply in the denominator by the same individual square root of 12. And they do the same in the numerator. When you have done that, that means now in the numerator, the square root of 3 times the square root of 12 is 3 times 12 underneath the same house. In the denominator, the square root of 12 times the square root of 12 is 12 times 12 underneath the same house. Then at the top, the square root of 3 times 12. 12 times 3 is 36. In the denominator, 12 times 12 is 144, right? Then, what is the square root of 36? It is 6. The square root of 12, it is, square root of 144, sorry, it is 12. What is 6 divided by 12? It is a half. So this is another way of doing the same question when we rationalize Mr. Denominator. Okay, totally different approach, but at the end of the day, it leads to the same answer. No calculator used, simply used our surd and root knowledge to simplify the given numerical fraction which has a surd. Okay, so I hope, guys, you can see that really and truly, when we are well versed in our rules, when our rules for mathematics are known, then it is easy to basically look at a problem and be like, okay, me, I choose this approach. Me, I choose to do it this way. Okay, let's move right along. We have this question. Let's look at it. This is 12 over 2 root 3 plus 3 root 2. But before I go on here, are there any questions about anything done in this first problem before I move on, thinking that we are all in the same page? Is there anything maybe you guys are not clear about? Right? Anything. But don't be someone who just joined and be like, can you explain the entire question again? That is tough. That is tough. Tough. But you can ask if there's any question, guys. Don't feel like now, because I've said to you, don't ask. Now you don't want to ask. Okay. Then I'm going to turn my attention here then. 12 over 2 root 3 plus 3 root 2 in the denominator. What is happening there? We have 12. In the denominator, we have 2 root 3 plus 3 root 2. This entire thing says to you, we have a situation where we have irrational. So, irrational number. will be the result. An irrational plus another irrational number will lead to an irrational thing. So we can see this is 2 root 3, 3 root 2. Somehow the surds need to go. So this one, clearly we are going to have to do what? Multiply by the unique one. Unique one. How are we going to form this unique one? The denominator will be our guide. How many terms are in the denominator? And what is the sign separating the two terms in the denominator? So what are we going to use? What is that thing that we called it? We called it a special name. We are going to multiply by what in the denominator so that we can actually pattern that for the numerator expression as well, and then multiply by it, and hopefully get rid of the surd. Multiply by the, thank you, that melanin girl. You who is chocolatey, melanin girl. I think you were the first one to actually say it. Conjugate, yes, the conjugate. So let's go ahead and multiply by the conjugate. What did we say, guys, are the components of a conjugate? Conjugate, when we multiply by it, has what, guys? The same terms. So 2 root 3 is going to be there. 3 root 2 is going to be there. The only difference with our conjugate is that instead of there being a plus, we are going to write what here? A minus. Thank you, Ciso the hustler. You are truly a hustler there. For sure, for sure, for sure. Then that means whatever then is multiplied in the denominator has to be multiplied in the numerator. So we are going to pattern that in the numerator. That same expression in the denominator is what we are going to pattern it after in the numerator as well. So we are already one step close. Now we need to just make sure that our multiplication is top-notch and we'll be good to go. 12 we multiply by 2 root 3. We get 24 root 3. 12 we distribute to negative 3 root 2. We get negative 36 root 2. Okay. Little Lee, you'll be surprised. We don't mess around. We don't mess around. Join the movement. Now here, this is the reverse of difference of two squares. So when you understand difference of two squares, there's no need for you to even think about, the multiplication of what's in the middle. You are going to focus purely on multiplying this with that, getting the answer. So we have 4, because 2 times 2 is 4. Then there you are going to have a root 3 times 3 inside the square root. Now you could distribute for your 2 middle terms, but you know that you are going to subtract them and get 0 in the middle. What you are interested in is just the last, which is going to be minus 9 root 2 times 2. Okay, you're not even going to focus on this and that, because that is all going to give you 0 anyways. In the middle, this times that, you are going to get a certain value, 6 root 6, and then here as well you are going to get another minus 6 root 6, which is going to give you 0 in the middle. So I'm not even going to focus my attention on that. I know I have 0 in the middle. Let's focus on what is there. 24 root 3 minus 36 root 2 in the numerator. The denominator has 4. Guys, 3 times 3 here will give me 9. Do we agree? The square root of 9 is going to give me 3. So this is 4 times 3 minus 9. Okay, 2 times 2 is 4 underneath the square root. The square root of 4 is 2. So that's 9 times 2. Okay. Now, please understand why I didn't waste my time multiplying. I multiplied the first and I multiplied the last to get the first, the first term and the last term in the expression, because I can see this is a plus and a minus for the same terms, which means difference of two squares, the reverse of difference of two squares. So it's the square of the first and the square of the last. That's what I care about. The middle terms will give me 0. I did not bother myself with that. Okay. Yeah, and that's because I'm proficient in my understanding of my grade 10 and my grade 9 work. I can see what this is. The reverse. Okay. The factors of a difference of two squares. Okay. So, yeah, let's continue. Say, isn't it 4? What isn't 4? What's 3 times 3? It's 9. What's the square root of 9? It's 3. What's 2 times 2? It's 4. What's the square root of 4? What's the square root of 4? What's the square root of 4? It's 2. So it's 9 times 2. See, so the hustler, why not 4 root 9? Which 4 root 9 are you talking about? Yes, so the hustler, I've already gone a step ahead of what you are thinking. 3 times 3 is 9, so it's 4 root 9. What's the square root of 9? Isn't the square root of 9 equal to 3? So I've gone a step ahead of you. All right, just gone a step ahead of you. Okay, root 9 is root 9, but the square root of 9, isn't it 3? 2 times 2 is 4. The square root of 4, isn't it 2? Does that make sense? So yes, you could write that step, right? The 4 root 9, that's fine, just as long as the simplification will happen. Okay, please ask all the questions you need to ask, guys. Me, I'm just simply, jumping the process, because I can see 3 times 3 is 9. All right, that 9 underneath the square root will give me 3. So in other words, it's actually 4 times 3. This here is 4 times 3, which is actually 12, the first term. Then this last term is 9 times 2, which is actually 18, negative 18 in the denominator. But let's carry out the process. So that's 12 minus 18. 12 minus 18 actually gives us what, guys? Negative 6. So we have 24 root 3 minus 36 root 2 over negative 6. Then, guys, in the numerator, there is an obvious highest common factor that you can take out there, which is 4. All right, and I think that can actually simplify even further, right? I think we can simplify that further. Yeah, it can simplify even that much more further. Okay, highest common factor, 12. Very good. See, it's a family, it's very helpful there, 12. So then if we take out the 12, we are left with 2 root 3 minus 3 root 2. And that's all over negative 6, which eventually 12 divided by negative 6. That gives you now a positive divided by negative is a negative. So that's negative 2 into 2 root 3 minus 3 root 2. We distribute the negative 2. That gives us negative 4 root 3 plus 6 root 2 as a final answer. Okay. Remember this 12. Okay, in the numerator, I now have one term because it's 12 and brackets. Then in the denominator, I have one term, which is negative 6. This 12 and this negative 6 can actually be simplified. A positive divided by negative gives me a negative answer. 12 divided by 6 is 2, and negative 2. And the negative 2 you are going to multiply with what is in the brackets, which is 2 root 3 minus 3 root 2. You take the negative 2 inside. Negative times a positive is negative. 2 times 2 is 4. And then it's negative 4 root 3. You take the same negative, you distribute it to this bracket here, this term here. Negative times a negative is positive. 2 times 3 is 6. And then the root 2 next door. That's your final answer. Do we have a root in the denominator? Not anymore. So that answer has been simplified completely, fully, and properly. Okay? Completely, fully, and properly. So let me just go back a little bit here. Very good. Nomathemba mthethwa. Okay, where did the 12 come from? Let's look at it. Let's look at this one more time. So here, hopefully we get the point from the 24 root 3 minus the 36 root 2 over 4 times 3 minus 9 times 2. Okay, then we have 12 minus 18 in the denominator, which gives you negative 6. Here at the top, there are 2 terms. So what we do is we factorize. Okay, we are simply applying, okay, a grade 10 concept. Okay, because if we look at 2 terms and there is an obvious highest common factor that we can take out, the only way we can be able to simplify with the denominator is if we take out a highest common factor, which between 24 and 36, if you look at 24 and 36, the factor that goes into 24 and 36, the highest number that can go to 24 and 36 without leaving a remainder is 12. So you take it out. When you take it out, cancellation of 12 and negative 6 is possible because you are going to check between 12 and negative 6, which one is the highest common factor. What is the highest common factor between 12 and negative 6? It is 6. So 6 goes into 12 2 times and 6 goes into 6 once. So you have 2 divided by negative 1, which gives you negative 2 for your outside number. Or you can say 12 divided by negative 6 is negative 2 in the numerator. Okay? Then you take the negative 2, you distribute it to the 2 terms, which is very important, which will lead you to negative 4 root 3 plus 6 root 2. So this is simple simplification, grade 10 simplification that you are applying here, because whenever you want to simplify a fraction where there are 2 terms in the numerator, or there's a various number of terms in the numerator and the denominator, you always check first, can you factorize? Is there a highest common factor in the numerator for the 2 terms that you have there? Then you take it out so that simplification can happen. Remember, the taking out of the highest common factor makes it so that you have 1 term in the numerator, which then leads to your simplification being able to happen. We cannot cancel across an addition or a subtraction sign because there are 2 terms. But the minute we have 1 term, because we've opened or taken out a common factor and there's a bracket, there's 1 term, we can now cancel between what's outside and what is in the denominator. Simplification can happen without any problem. Thank you, Zamani MacFam, for the roses. I really appreciate it. 2 of them. Really appreciate. I think you, as it says the first gift you've ever sent to me personally. So thank you so much. I really appreciate that. It is much appreciated. My gratitude goes out to you. Thank you. Okay, Nomathemba Mthethwa, I hope you are sorted. Okay, any other questions, Nomathemba? Or any other questions from anyone in the comment section? Guys, are we getting the hang of this? The conjugate. Okay, because the only grade 11 concept that is here is this idea of the conjugate. Everything else, guys, is not grade 11. All right, everything else that you are doing is grade 10 simplification for your fraction. Okay, because what is this? FOIL. This is grade 9 and grade 10. Okay, after you multiply out and you get your expression, what is this? All of this, the square root of a perfect square being 3, that's all grade 8 and 9 numerical number simplification. Number simplification you did in grade 8, guys, really and truly. So all of this is just you making sure that all the grades work that you've done over the years is coming together and you are able to have a solid outcome. because you know what to do in each step, because you have been able to get the required exposure. So that's why practicing maths is important. Please, guys, practice. Don't overlook this aspect of continuous practice, so that you can actually make sure that you are solidifying all these concepts very well. Okay. I don't know if there's any questions. If there are any, I would love to entertain those questions. Okay. I think this one is for you. I'm not going to do this one. You can do this one. This one is for you. I'll give you 5 minutes. The time is 5:27. At 5:32. Okay, because I'm going to actually, I'm not actually planning to stay for long. The concept for rationalizing the denominator is what I wanted to teach today. So grade 11s, that concept now, I think I've overstated it. It should be clear for all of you. Now your obligation is to now go and practice. I will post some questions for you in a video that I will do on TikTok just now, just for the grade 11s. I did that for the grade 10s earlier on today, so that when we meet again, which is tomorrow, we will then do those corrections. So I'll post questions for you. I don't know. I'll post some questions so that you can have some work to iron out and do, because you need to apply the maths. You can't just be like, I understand it, sir did it. No. I am the one that understands. You must understand by doing. I will know for sure. You will know for sure when you do the work on your own that you understand. Okay, here's the question for you. Okay, let me just, for the purpose of those that like screenshotting, these were the 2 questions. So hopefully you can see the 2 questions. This question, obviously, that I've just answered now, and then that one. I want you to do number 3 and 4. Number 3 and 4, that's for you. Okay, but let's start here. Yoli, maths is a game. Answer is -1. Okay, I see you there. Yoli. Yoliza. That's what Yoli is saying. Yoli guy 1, Yoli guy bini, Yoli guy 2. Thank you guys for 11.8k likes. Love it for myself. You guys are really putting me up there. 11.8k likes. Good morning, Solve 3. King Lawrence, you just send me a galaxy there. Instead of saying good morning, Solve 3, just send me a galaxy and I'll be very happy. Just send me a galaxy, my guy, and be. Some of you, I can see you are trolling, eh? There's many trollers here. Uzizwa kanjani? Good morning, my foot, guys. What is this? Are you guys trolling? You guys are trolling bad. Good morning, my foot, man. Is it morning? You just woke up because you had a late night. Now we are supposed to say good morning because when you just got up from bed, 5:30 p.m. Kidding me. No, I'm waiting for people to do it. What are you talking about? Do number 3, please. You are late. Gee. This boy. You even have the audacity to laugh sideways at an angle. It can't be different time zones. Never. 19? Soze. Nobody can equal me. Soze. Oh, maybe it is. Okay, maybe it is. Maybe I'm just on his case, Shem. Poor guy. Gotten the bitter end of my stick. Alright, no. Maybe it is. You are probably 100%. It's morning though. 19. Where are you from? 19. Where are you from? Which country are you from? It's fine. It's morning though. Let's just establish which country are you from. 19. Okay, grade 11s. Let's let's get this party started, grade 11s. Let's see, how do we take care of this? The answer is 1. See, so the hustler is also confirming that. Especially, yes, it's for grade 11, William the Goat. The hustler has confirmed. If the hustler is saying the answer is 1, okay. Initially, someone said the answer is -1. Hustler is saying it's 1. Okay, so let's check. Bangladesh. Okay, no. I get then time zone is definitely different if you're from Bangladesh. Good morning then. Sorry for the rod that fell in the wrong place. Surd plus minus bracket root 5 root 2. What do we call this? Conjugate. The unique one that we are going to multiply by. So this is what we are going to multiply by, the unique one. Okay. So then that means 2 terms. We're going to have to put brackets there as well so that we can apply who? Mr. Foil. Apply Mr. Foil. So at the top, we are going to apply Mr. Foil. And then at the bottom, we're also going to apply Mr. Foil. We are going to have to carry it out completely here. Here, we are going to carry it out, obviously, completely, but we know what we know, because this plus and this minus means this is the reverse of difference of 2 squares. So let's start there at the top. Square root of 25 times the square root of 25. That is simply what? 5 times 5 underneath the same square root, which is 25. Minus 5 times 2 underneath the square root, which is square root of 10. Minus 5 times 2 underneath the square root, which is square root of 10. Minus underneath the square root, we have 2 times 2, which is 4. Again, square root of 25 underneath the square root. But we know, guys, as I said, since this one is plus and minus, the reverse of difference of 2 squares, where does the 15 come from? I don't know which 15 you are talking about, but anyways, whatever you say. Why do we minus say for root 2? Why do we minus say for root 2? When a root multiplied by a root, it cancels. Okay, all of these things that you are saying, minus times equals plus at the top, say. Okay, very good. Okay, so you guys noticed my error. Very good. So here, this, okay, let's just review it again. This times that, we agree it's square root of 25 underneath. Okay, because 5 times 5 underneath, guys, the law, we did this yesterday. We said the square root of 5 times the square root of 5 is the square root of 5 times 5, which is 25 underneath the square root, which is 5. Let's be careful, né? Yeah. Okay, that's basically one of the ways that we look at it. Some of you are probably looking at this way. You are changing the square root, right, to 5 to the power half times 5 to the power half, which is 5 to the power half plus half, which is 5 to the power 1. So in other words, same thing. Okay, does that make sense? Right? So whatever way you want to look at it, as a root or as that root converted to exponential form, you'll still get the same answer. Okay, all right. So what I'm saying is, because I'm dealing with the roots, this is square root of 5 times 5, which is the square root of 25. This times that, underneath the root, we are going to have 5 times 2 underneath the root, which is minus the square root of 10. This times that, a negative times a positive, the negative, underneath the square root of 5 times 2. Then we can fix what I did wrong, of course. Very good, Carabello. Negative times a negative is not negative, it is positive. So thank you so much for that beautiful fixing. You guys fixing me gives me so much hope. It says to me that you guys are going to do above and beyond even what I'm doing. You guys are just going to destroy the maths this year. You are going to do something amazing. If you can fix me in the live, then it means you guys, you are the fixers. You are going to get, guys. We must work for this. 95% to 100%, we said, is basically, this is the minimum of what we are aiming for. This is what we get when we master everything. Perfection. But because perfection tends to fall short, we are going to give room for allowance that people can at least get a minimum of 95% for maths term 1. Are we together? Yes, we are going to fix maths, Carabello. Yeah, we're going to fix it. We're going to fix the dire situation that we're under. We are going to fix it. So this times that gives us that. Guys, this times that one, that will be negative. This times that one, that will be positive. Then this times that one, that will be negative. 2 times 2, which is 4. No, Presh, we are busy with grade 11. We're doing grade 11. I never do grade 12 this time. Never do grade 12 this time. This is just grade 11. Surds. Alright? Okay. Then, at the top, we have square root of 25, key 5. Minus root 10 key minus 2 root 10. Square root of 4 key 2 over square root of 25 key 5 minus root 10 plus root 10 key 0 minus 2, because square root of 4 key 2, that's 5 minus 2. Continuing on, what's 5 plus 2? Key 7. Those are like terms. This here is minus 2 root 10 over, what's 5 minus 2? Key 3. Anything more that can be done with this question? No way, Jose. Final answer? I don't see negative 1 here in the final answer. 2, I don't see positive 1 in this answer. The only thing I see is 7 minus 2 root 10 over 3. And I cannot simplify this any further, it looks like. Okay, unless someone can say, I disagree with you. So around what time? You guys are always doing 9. I do 9, guys. 9. Right? For grade 12, it's 9. Okay. Step 3. Kehla Golit. Step 1, step 2. Square root of 25 minus square root of 10 minus square root of 10 plus square root of 4. Denominator. Yes, Debo. It is minus square root of 10 plus square root of 10 minus square root of 4. Habiba. Never. Explain step 1. Never. Okay. Step 1 has already been explained. So guys, this is for you.